Welcome to Pipeline Conversations, a machine learning podcast by ZenML. This week, we spoke with Danny Leybzon, currently working with WhyLabs to help data scientists monitor their models in production and prevent model performance from degrading. He previously worked as a kind of roving data scientist and engineer, helping companies put their models into production. As such, we had a really interesting discussion of some of the ways that tooling and the general context for data scientists sometimes lets practitioners down. And of course, we also discussed why monitoring and logging is actually a kind of baseline practice that should be part of any and every data scientist toolkit. Luckily for us, Danny added in a bunch of examples from his wide experience doing all of this in the real world. So let's get straight to the interview. Maybe the most interesting place to start is just to talk a little bit about your personal experience. I know, at least from the outside, it seems like you've had a bunch of years where you've been working to develop, deploy machine learning models, working with people who do, helping them, particularly at kind of various degrees of scale. And I'm just curious, how has that experience been? What have you noticed along the way?
So I guess to give a little bit of historical context, I started getting exposed to MLOps before MLOps was a word, right? I was working as the product manager for data science and machine learning at a company called Qubole, which offered Apache Hive, Apache Spark, and Presto as managed services. And part of the Apache Spark offering that we had was targeted at machine learning engineers, which didn't really exist as a category yet, and at data scientists. So I was thinking really hard at the time, how do I help my customers, these people that I see really struggling with taking the models that they've built in Spark and transfer them from the sandbox environment where they've been developing these models into a production environment where they're actually creating value for their business. And I proposed a couple of different options, like using Airflow to kick off a scheduled task for batch inference, or using Spark streaming for taking this Spark machine learning model and streaming data into it and using it as a transformer effectively in order to generate the inferences. But then I was at the AWS reInvent when they announced SageMaker. I think this was 2017, 2018, something like that. I was at this reInvent and I was like, oh man, this thing is cool. Like AWS figured out with SageMaker so many of the problems that I thought needed to be solved. And I was ready to just throw in the towel and give up. And then I started using the product and I was like, oh, this is cool, but there are still some gaps. And I talked to data scientists and they were like, yeah, this is really useful, but there's a lot more that needs to be done. So ever since then, I've been really involved in trying to take data scientists' work, take these machine learning models and actually get business value out of them instead of just, the cool interest and intrigue that we all get from developing cool models in a sandbox.
Continuing on from what you were just saying, in places where you've seen things work, have you seen people making clear distinctions between the experimentation stage and the deployment stage? Have you found like a more of a hybrid approach works? Is there any specific examples that you can talk about?
So I think Stitch Fix is a really interesting example in this situation because they actually require all of their data scientists to be end-to-end data scientists. Like they own a project, a machine learning model, all the way from cleaning the data and preparing it, all the way through to deploying and even owning it after it's been deployed. Now, like this is Stitch Fix. They're able to hire some of the most amazing data scientists and machine learning engineers in the world. And even they struggle with getting people who have the skills to own everything end to end. I think more realistically, there's always going to be some amount of functional separation, some amount of specialization that exists between the people who are like coming up with new algorithms, right? Research scientists. B, people who are applying those algorithms to models, data scientists. And then C, people who are taking the models developed by data scientists and deploying and owning them in production, machine learning engineers. And I think that this will always be the case because these are three fundamentally very different skill sets. And it's really important, obviously, for data scientists to be talking to machine learning engineers to understand what's going on in their space and to be able to help transfer models to them. But I do think that machine learning engineers have a very distinct skill set from data scientists, and that we will continue to see the specialization that we've seen thus far.
So Stitch Fix is actually a really cool example, and I also talked about that in the last podcast where they had a really famous blog by Eric Colson who talked about the comparison between a division of labor pin factory in the old manufacturing days. The principles that were used there do not necessarily translate into the data science workflow, and how they found that empowering the data scientist and making them own the entire process, as you said, was ultimately super beneficial because of all the moving parts that are involved in machine learning in production. So, do you feel like this is where the role of higher level abstractions comes into play? Because it feels to me that in these handoff points, you can use tooling and systems and processes to make abstractions that make the lives of data scientists easier. Um, for example, a data scientist doesn't necessarily need to know about Kubernetes in order to be able to deploy a service or a pod there, if the right process and right tool is used. Do you have any thoughts on that?
Yeah, absolutely. That's a really good point, Hamza. I think you're right on the money that really good tooling can really simplify the lives of data scientists and even potentially make it less important to have machine learning engineers owning the process. And I think ultimately a big part of this comes down to the fact that there aren't simple rules that can be applied to every single person or every single industry or even every company, right? Because there will be some companies who are at a scale where they're not buying any external tools at all and they're only developing things in house. And at those types of companies, it's much more likely that there's not going to be a perfect tool that will line up with exactly the needs of that company. And therefore, they'll have to still be investing a lot in their machine learning engineering practice. But conversely, you're totally right that there's a lot of companies who would benefit from just investing in more powerful, easier to use, much more convenient tooling that can simplify the handoff or even make it possible for the data scientist to own the whole thing end to end without having to become an expert at DevOps, at engineering best practices, without even having to really understand observability or monitoring best practices, but just use a tool that enables them to simplify the process of deploying.
Sure, yeah, that makes sense. But on the other hand, do you also see if the abstraction separates these roles too far apart, that there's a problem of understanding between each other? So if the data scientist and the engineer are too far apart, have you seen problems occur in production because of that separation as well?
Yeah, we absolutely see problems related to exactly what you're discussing, where because of the moat, the separation that's drawn between data scientists and machine learning engineers, and because of a lack of shared language, especially around what needs to be done in order to get a model and get it to create value for the business, we see, like for instance, in WhyLabs, one very particular example of this is that we suspect, we hypothesize that users need to be logging data throughout the entire process, that they need to log data when it first gets generated, that they need to log data after it's been transformed, that they need to log data when it's being sent to the model, and then they need to log the inferences that are being made and maybe even the ground truth after the model has already been served, after the data has already been inferenced against. And what we see is that because there's such a gap between data scientists and machine learning engineers, what ends up happening is that a lot of data logging and a lot of monitoring and observability only happens at the very end of the deployment phase, which we see as being a big gap because when it is time for the machine learning engineer to come back to the data scientist and say, hey, we're seeing performance degradation of this model or we're seeing even model failure, the data scientist is at a loss as to what to do because they don't have a historical record of what's been done to the data because they haven't been logging. So this is one very particular microcosm, one very small example of the dangers of siloing, which happens as a result of specialization without communication between the functions.
Yes, and to address that, there we have seen an explosion of ML and MLOps tooling in recent years, causing a fragmentation in the space.
I think that there's always going to be some level of fragmentation, right? Like, I don't think there's going to be a clear winner in the cloud market, for instance, which I think will inevitably result in different people using different MLOps platforms. But I don't think that that means that we can't come together and agree on standards that we use across all the different platforms. And especially, I think one of the things that I'm really impressed with what ZenML does is how you guys are able to act kind of agnostic in a lot of ways to a particular platform and run as an abstraction on top of it. So, and at WhyLabs, we try to do something similar where we try to be totally unopinionated about how our customers are using our logging tool, whether they want to use it in Spark or in Python, on image data, text data, on tabular data. There's a lot of different types of problems out there to be solved and a lot of different solutions to those problems. So I think that there's going to be a lot of value to the products and the solutions that are able to integrate with lots of different other platforms, lots of different other tools, and act either as kind of a glue or act agnostically to the particular underlying, be it a deployment platform, be it a training platform, whatever it might be.
So obviously, like a lot of the MLOps kind of tooling is being driven, I guess, from one end, from kind of an engineering standpoint. Like I don't see so many tools which are being developed necessarily by data scientists themselves. Do you see where we are right now as just this interim period that is just part of the evolution of these tools, just like software engineering went through maybe its own kind of period of development, or is there something a bit more, long lasting about this kind of weird interim status? Where is the innovation or the drive for changing this status quo going to come from, do you see?
I think it's going to be really bottoms up. I think we're seeing a lot of top down innovation, right? Like really big companies coming out with their internal tools that they're using, or even just going straight to commercial options like the managed service offerings on AWS or GCP or Azure. But I think what we're going to continue to see, and honestly what we've already been seeing, is that users have problems. A lot of solutions don't solve those problems. And as a result, they need to create their own solutions for these problems. So what we see already and what we're going to continue to see is a lot of bottoms up development, not necessarily by data scientists whose expertise isn't building software, but rather is analyzing or getting value out of data, but by the people who are working with those data scientists, often machine learning engineers, maybe data platform engineers, all of these different types of engineers who work alongside and support data scientists are going to continue to develop tools both internally as well as facing the market to fill in gaps that they see.
I completely agree with you. I think there's going to be a lot of innovation coming in the tooling space, bottoms up. But there is one particular observation that I've made personally, which is that the tooling that is coming out for data scientists, things like Streamlit or Hugging Face, and the tooling which engineers love to use, something like Terraform, infrastructure as code, they have very distinct properties, and the levels of abstractions are quite different. And they don't necessarily conform to each other's processes, right? So it's quite distinct the way Streamlit functions to how you would want to deploy on a Kubernetes cluster. Have you also made that observation with these like different layers of abstractions and how they have to mingle with each other, or do you see that as less of a problem and something we'll figure out over time?
Yeah, and to get a level deeper into it, I think I'm actually seeing like different levels of abstraction wanted by different machine learning engineers as well. Like it's not just the data scientists versus machine learning engineers who want different levels of abstraction, but depending on the priorities of the business, the expertise of the particular person, different machine learning engineers and as well as different data scientists might want different levels of it. Like there are some data scientists who are really happy using these model as a service approaches like Hugging Face, but there are other data scientists who, either because of the nature of their work or because of their expertise or whatever it might be, are still training their own models, are still gathering their own data, are still needing to do a lot of this stuff themselves. Just like, in the parallel to draw in the DevOps world is there are a lot of people who are using Terraform and using infrastructure as code. There's a lot of people that are still just like manually spinning up EC2 instances, and not necessarily for, production facing use cases, but there still is a lot of manual interaction where people don't want that higher level of abstraction. So all this to say, I think you're right in picking up that data scientists do often want a different level of abstraction than machine learning engineers or data platform engineers or whoever else it might be. But I also want to add some nuance that there's, as you mentioned, there's a Cambrian explosion in tools. And similarly, there's a lot of different types of problems that people are trying to solve, which means needing tools at different levels of abstraction.
So something I've noticed is not only has the kind of, yeah, obviously you have this tooling explosion, but I think we're seeing also as time goes on and as I guess the abstractions get a little bit higher, you also see more and more domain experts coming into, I don't know, places which in the past maybe would have been occupied by data scientists, but now you just see more and more kind of people with slightly less technical experience, but who are wanting to make use of kind of new techniques and technologies that are developing. Do you think this changes things in any way in terms of where the tooling goes?
Yeah, absolutely. I mean, that's a great point and a trend that's been picked up on really broadly by like Gartner with their coining of the term citizen data scientist. I think back to the old days of the three-part Venn diagram where data science is explained as the intersection of software engineering, statistics, and domain expertise. And the more we abstract away the need for statistical expertise or the need for software engineering expertise, the more and more domain expertise comes into play. And we see this, this trend even starting kind of a while ago with Data Robot, with Data IQ, with these tools that really weren't targeted necessarily at data scientists who were training their own models and tinkering with the hyperparameters on XGBoost, but who rather were like, hey, I have a problem that I need to solve. I have a lot of experience with solving this problem analytically, but I don't want to have to be doing this stuff manually all the time. How can I use the innovations being made in machine learning and in artificial intelligence to simplify my job? So I think this trend really started maybe 5 or 6 years ago. But you're totally right that there's been an explosion in tools that enable domain specific citizen data scientists, and that these tools are very, very different than the tools that you and I are building that are really mostly focused. I mean, I don't want to speak for how ZenML is positioning itself, but from my perspective and the way that WhyLabs is positioning, really oriented more towards data scientists with more statistical and more software engineering expertise rather than the citizen data scientist.
Yeah, it definitely seems that there's a lot of almost trying to bake best practices into the tools, so that there's kind of a happy path which people can take just by using the software as it's meant to be used for people who maybe necessarily haven't come through a particular education path which is very focused on the particular intricacies of that discipline.
Yeah, absolutely. And these tools are doing a great job of building in Rails and really creating a really good experience, I think, for a lot of their users. But I think even with the explosion of these, super easy to use, really abstracted tools, there's still a big gap because there are still a lot of non-citizen data scientists, right? A lot of people whose career is entirely focused around their expertise in data as opposed to domain expertise in oil and gas or healthcare or finance or whatever it might be. So I do think there is still a lot of value in tools that are oriented at those data scientists as opposed to the citizen data scientist.
So speaking of tooling that is geared towards the data scientists who come from more of a coding background, a lot of these tools are monitoring and observability tools, like such as WhyLabs or WhyLogs, for instance. And just as a way of us to start talking about observability as a concept in machine learning and monitoring, let's start off with the basic question: why is monitoring in machine learning so hard? And why isn't this a solved problem yet? Why can't we use a Prometheus Grafana dashboard or like a simple Datadog dashboard to solve these problems?
Yeah, that's a great question. And it's one that comes up pretty often. Actually, it's funny that you ask it because it really just came up yesterday in a thread in the MLOps community. And I think that thread did a good job of kind of scratching the surface of why is it that ML monitoring and AI observability is fundamentally different than observability for software 1.0. And one thing that was pointed out by our friends over at Superwise, by Oren over at Superwise, is that in classic software, the metrics already exist for the most part, right? You've got stuff like CPU, like memory, all of these, like latency times, all of these metrics are pretty easy to come up with and therefore pretty easy to just pipe into a Datadog or, throw into Prometheus and visualize with Grafana and whatever it might be. One of the really big challenges in machine learning models is even figuring out like, what do I need to be monitoring about them? There was similarly in the MLOps community a thread a couple of months ago that was talking about, is it more important to monitor your input data or the predictions being made by your model? And the answer is that you've got to be doing both, of course, right?
All of the
But
above.
even like, what are the metrics about the input data and the output data that we need to be monitoring? Like, do we want to care about the percentage of null values, about the distribution of the data to be able to monitor data drift and changes of the data over time? So even like metric definition, which for software 1.0 was kind of a no-brainer, in the world of machine learning, because it's a much more dynamic space, it's a lot harder to even define the metrics that people need to be monitoring. And there's like laundry lists out there of all of the different types of metrics that you can generate from data in order to be able to monitor it effectively. So that's one really big gap in kind of the classic tooling around the space. And then I think the other big gap isn't just around the metrics, but also around the ways that the metrics are interacted with by the observability platform. So like a classic Datadog or Grafana plus Prometheus, right? Because it's built for classic metrics, it tracks classic metrics in a classic way. Like you can do standard deviations and track change over time, and maybe you can set a threshold to get alerted when things go wrong, right? But in order to define like what a significant amount of change is for a data distribution, this requires a little bit more tooling and even domain expertise, right? Like you need to know that you want to use KL divergence or some other distance metric to know that your data has changed enough that it's worth updating your model. So all this to say that there are a few different distinctions that make the old school tooling, like just classic StatsD plus Grafana plus Prometheus, no longer really viable for monitoring machine learning applications in the way that it is viable for monitoring classic software.
Yes, absolutely. And if I may, because I was seeing some of your talks and presentations that you gave regarding monitoring in machine learning, I was struck by one of the talks you gave where you spoke about how there's also different phases in this monitoring and tracking, right? So you have this experimentation phase where you're probably just doing iterations on the model and using like some sort of an evaluation set. You have the productionalization phase where you have maybe a test set that you're using, which should be non-biased. And then you have the production phase where actually you have real data that is exposed to the model, and that has a different sort of like modality to it, a different sort of requirements to that system. And all of these layers or phases also need to be connected together because you need to know what you did in the experimentation phase in order for you to take actionable like error handling if something goes wrong in the production phase.
Yeah, absolutely, Hamza, and I appreciate the level of depth that you went into researching the presentations that I've. So you're absolutely right in identifying that there is a really big problem in the fact that oftentimes people only think about monitoring once they've already deployed the solution, once they've already deployed the machine learning model. And one thing that this harkens back to is the point that I had made earlier in this podcast, which is that one of the challenges that we're facing at WhyLabs is trying to get people to know, trying to get especially data scientists to know that they should be logging data throughout the entire data pipeline, like all the way from when the data is getting generated all the way through to when it's actually in production. And one of the gaps that we see is that because observability and monitoring are kind of an afterthought for a lot of people, just like, to be honest, it was an afterthought for me when I was giving the presentation that you're referencing, which was really focused on productionization and kind of just the first step of deploying the machine learning model, which is by no means the end of the process. So because a lot of people only think about monitoring and observability when it's, at the end of the process, they miss out on a lot of value that comes from logging data and getting observability into the entire pipeline. Being able to debug data, being able to do unit testing early on, being able to understand what is the effect of this feature transformation on the validity of my data, on the completeness of my data, on all of these other different useful attributes of my data, all of that is being lost or at least being done not systematically because people are only thinking about monitoring and observability as something that happens when the model is already in production. Versus what I would posit. So at WhyLabs, our hypothesis, the thing that we posit is that actually data scientists and machine learning engineers should both be involved in logging data throughout the entire data pipeline, right? End to end, rather than just only thinking about monitoring and observability at the very end when the model is actually deployed in production and generating value for their business.
And it seems like a lot of these problems come from the way data scientists are taught about machine learning. And I know there's a change happening now, but I always thought that in these online courses, there could have been more of an emphasis on what to do in the experimentation phase to carry forward in production. And I almost feel like if there's like a Kaggle monitoring integration or competition or whatever, then it will already do wonders for the industry.
They're thinking of launching those platforms, I think, like competitions for MLOps, basically. They've been talking about that for a while.
I have never been in a situation where tools alone in a vacuum have been able to solve a problem. I think you're right on the money that a lot of this is people problems, right? That there is just a lack of education, historically a lack of conversation between data scientists and among data scientists about the needs to think about what happens after the model is in. And again, like I don't have a super strong hypothesis about whether it should be end-to-end data scientists or whether specialization is a better approach. I do think everybody benefits from looking over the fence and understanding what their partner organizations do. Like I think machine learning engineers get a lot of value when they talk to data scientists and ask data scientists about the types of models that they're using, about the types of problems that they're solving. And conversely, I think data scientists get a lot of value when they talk over the fence to their neighbors in machine learning engineering and ask, hey, what should I be doing to make my model more robust? How can I make it more performant? How can I make it easier for you to productionize all of these different things? Like this needs to be an active conversation. But whether it's that data scientists become this kind of unicorn data scientist who is an end-to-end expert in everything statistics, everything computer science, and everything domain expertise related. I don't know, like there's just not that many people out there who I think are motivated or even interested, and I'm not sure that it would provide sufficient value for organizations for every data scientist to be this like perfect end to end. Though the ones that exist out there, I'm sure would benefit a lot from the type of education that you're talking about, because I do think that there's a big gap in terms of educating both software engineers and data scientists in how do you get machine learning into production and how do you make sure that it provides a lot of value. I mean, that's one of the reasons why I'm a really big fan of your previous guest, Noah, right? Because Noah Gift's been going out and he's been evangelizing what you need to do for machine learning in the software engineering world and helping to raise the next generation of machine learning engineers. And I think it's really great that we've got people teaching and writing and talking about software engineering best practices in the context of machine learning, because otherwise all that's going to happen is these people are going to enter the industry having either gone through the kind of data scientist Kaggle pipeline or the like traditional software engineering university degree or boot camp. And then when the rubber hits the road and they're actually trying to get models into production, there's a gap in either their understanding of data science best practices or software engineering best practices.
On the flip side, though, it does seem like it probably doesn't hurt for there to be like a greater baseline vocabulary or baseline kind of understanding around, I don't know what the best way to describe it, just like a general savviness with statistics and I don't know, distributions of data or whatever, because you do suddenly have data as this key element to the process now. And I don't know, I wonder whether that's probably something which is also a bit lacking from someone coming from a purely engineering background, where they don't bring that into their understanding of the problems.
Yeah, I mean, absolutely. Just in general, I think as somebody who studied statistics and loves the application of probability theory and statistics, I think everybody should learn more about statistics. I think it is the most applicable mathematics, and it's so useful and informs so many ways that we can think about the real. Whether I expect every software engineer to have a PhD in statistics in order to be able to work on machine learning models, I think, probably unnecessary. But absolutely having a shared vocabulary, both around statistical or data science best practices and terminology, as well as around software engineering best practices and terminology, I think will be really, really useful for making sure that machine learning models get deployed in ways that are scalable and efficient and are providing a lot of value for businesses.
Awesome. Yeah, I mean, I think that we've sufficiently made the audience aware now of the general problems around not doing monitoring or observability best practices while deploying machine learning models. But I'm wondering whether we can make it a bit more concrete. So usually, the listeners, they really appreciate if our guests tell us some war stories that they know about things that go wrong in machine learning in production if you don't do these things right. So, for example, we had the famous Alexillo example, classic concept ref, model ref problem, which happened and cost millions basically to that company. Do you have any story for us to share, perhaps in a concrete way, so that our listeners could also pin certain keywords that they could maybe search for afterwards, just to learn a bit more about the things that could go wrong?
Yeah, so I'm gonna tell a story with a happy ending because as important as it is to scare people, I want people to know that there is like a light at the end of the tunnel. So this is a really prominent example that Google has gone public with and told the world about that in Google Health, they had developed an algorithm that helps to identify a medical issue. I'm not remembering right now whether it's diabetes or something related to sight and vision, but basically, they had developed this algorithm, this machine learning model, that makes it a lot easier for nurses without the intervention of doctors to be able to very quickly diagnose this problem, right? And they do this by passing an image of the patient to the machine learning model, and then this image is processed, and a diagnosis with a confidence level is returned back to the nurse. So, okay, this model is performing great at the Google offices in Mountain View. It's really successful. They're getting really great results. They pass it off to nurses working at a hospital in Thailand, and all of a sudden the results are like ridiculous. Like they're just dumb. And the nurses are able to immediately identify, there's no way this person is sick with this disease. This just is not a good example of this. And they come back to the engineers, to their partners at Google and say, hey, like, why are you giving us this terrible model? How badly did this thing do that you decided that it was worth passing off to us? And people at Google were like, we don't know what you're talking about. It worked great. And then they started comparing the images in their training data to the images that were being passed to the model in production at this hospital in Thailand. And it turns out that they were super different images, right? Because the nurses weren't being trained to take the image in the same way that the technicians at Google's laboratories were doing it. The technology being used, the like hardware being used was different. There were just all of these differences. And one very fundamental fact about machine learning models is that even though they generalize, they're not able to learn more than what the training data tells them, right? So if you have out of distribution examples, if the images that you're passing to your model are different than the images that it was trained on, you can't expect your model to be able to perform well. So with all of this out, the data scientists, the machine learning engineers at Google sat back and said, okay, I guess we shouldn't be coming up with our own data sets. And I guess we need to be really thoughtful about training and gaining expertise in the technicians, these nurses, so that they're able to pass the same type of image to the machine learning model as the one that it's being trained on. And fortunately, they were able to redeploy this model, and it's been providing value in a very impactful space ever since. But this goes to show that even in a super impactful, very human industry like healthcare, even by a very experienced, very machine learning first company like Google, these types of mistakes still happen. And the solution to this is, of course, being able to monitor the model in production so that you're able to identify the problem and able to identify this out of distribution data being fed to the model before the nurses even realize that there's an issue and before they come back to you and are able to say, hey, there's training serving skew that you need to resolve, right? Because if we think about this from a customer experience point of view, if we imagine that it's not, nurses who know to push back on bad inferences being made by the model, but rather bad recommendations being made on, I don't know, whether somebody can get credit, and there's not the introspection or the ability to see the performance of the model, then they never would have known to retrain it, and the model would have still been giving bad recommendations. So all of this to say, this is all the reason why ML monitoring and AI observability, the ability to really interact and debug the model in order to understand what's going wrong, are really important for bringing models into production and for getting value out of them.
Yeah, for sure. I mean, having that kind of feedback into the process is really great. I wonder a little bit, having rapid feedback and having things always part of networked more or less in real time about what's going on with a particular model and the inference and so on. Like, I wonder a little bit about the application of some of these technologies to places where you don't have such a quick feedback loop, and it's a bit harder to iterate in that sense.
Yeah, absolutely. And that's why, us at WhyLabs and our friends at other organizations think not just about, monitoring the performance of the model, which is pretty easy to do, right? Like in a forecasting use case, it's pretty easy to track like your precision recall, it's pretty easy to track the performance of your model. But when you don't have the ground truth being fed back to you very quickly, when you've got really long feedback cycles, or maybe even the need for human labeling, which means no automated feedback cycle at all. In those situations, it's much more important to be monitoring the input data as well as the distribution of the predictions being made. Because if there's a big shift in those predictions being made or in the input data, that might be indicative of the fact that the model that you've trained is no longer accurately able to represent, no longer accurately able to model the real world.
Okay, again, I have to say it. We did not pay Danny to pay that compliment. Thank you, Danny, so much. We really appreciate what you guys are doing over at WhyLogs and WhyLabs as well. I think it's Alex. It's time for the last two questions, who we ask every guest. So I'm super curious about Danny's answers here.
Yeah, sure. So just your kind of whatever comes to mind for these. In terms of a quick win that someone might be able to add to their ability or to their kind of current stack of productionizing models, like how would you? Is there something which comes to mind to allow them to make this a bit more robust?
Yeah, I mean, this might be a little bit self-serving, but you did invite somebody who works on the WhyLogs project here. So to me, like the ultimate low-hanging fruit for how do you make it easier to create robust models is pip install WhyLogs and start using it through just a couple of lines of code to log your data so that you have a log, a record trace that you can use in order to understand how your data is being used and in order to understand changes in your data so that you can make the model that's being trained on it and that it's being used to inference in that model more robust.
Nice. And I have an idea of kind of your answer to the next one as well. But what's one part of putting a model in production do you think that people should be giving more attention to by tool makers in the MLOps space?
Well, I don't know that we need, any more ML monitoring or AI observability tools. I think we've got some good ones out there already. Honestly, I think the stuff that Zen is doing is really interesting. And I think it's very unique in the space from what I can tell. So I really love, the ability to create abstractions and the work that y'all are doing to make it easier for people to use different types of underlying platforms and other types of tools in order to bring models into production and in order to get value out of them. Because I think, again, hearkening to the earlier point that we were talking about and making, like there's been a Cambrian explosion in tools, and it's going to take us some time to whittle down from this explosion down to the most successful, the most value adding tools. And I think in the meantime, what we have to do is accept the fact that there's a lot of tools out there and find tools that are able to create abstractions so that we don't have to learn the underlying components of every single one of these. I guess a good comparison to be made is to Keras, right? Which was able to make it easy for users to use TensorFlow, but also PyTorch and lots of other different deep learning frameworks so that they didn't have to learn the particularities, the particular syntax and idioms of those APIs.
Fantastic. All right. So, Danny, thank you so much for coming on. This has been a really insightful podcast. We're gonna play you out with some music. Just let the good people out there know how they can reach out to you, what you're up to, and any other good stuff that you have going. So, take it away.
Absolutely. So you can reach out to me on Twitter, where my handle is at DLEYBZ. So D and then the first few letters of my last name. I'm very active on LinkedIn, where you can find me at Danny.Leybzon with a mountain emoji at the very end of it. And then another really great place to get in touch is in the WhyLabs Slack channel. So if you go to bit.ly/WhyLogs Slack, you'll get sent a recommendation to join the WhyLabs Slack workspace. And there, I or one of the many talented engineers working at WhyLabs is happy to answer your questions. The classic call to action that we have is if you've been interested in the data logging, the WhyLogs open source component of this conversation, I recommend that you check out the open source project. You can just Google WhyLogs or go to our GitHub or go to bit.ly/WhyLogs. And then if you're interested in AI observability, if you're interested in ML monitoring, you can actually try the only fully self-serve, fully SaaS platform out there for AI observability and ML monitoring by going to whylabs.ai/free.
Thank you for listening to this latest episode of Pipeline Conversations. If you enjoyed what you heard, please consider giving us a review wherever you get your podcasts. It helps us get seen by more people, and of course, it's always nice to receive feedback. If you have suggestions for future guests, please send them over to podcast@zenml.io. Thanks. Until next time.